Let's begin by drawing two parallel lines, M and N. These lines can be moved in many ways, but they always remain parallel. Now we will draw a transversal, T, that crosses M and N. Let's investigate the measures of the two highlighted corresponding angles. The measures of both angles are now 43 degrees. Will they remain congruent as the positions of the transversal or of the parallel lines change? As the transversal moves, the angles change in size. Here, each of the angles is 24 degrees. What happens to the positions of the lines as the angles become smaller and smaller? These corresponding angles can become very small. Here, each of the angles is 5 degrees. What do you think will happen as the angles get closer and closer to 0 degrees? The angles can get closer and closer to 0 degrees until the three lines finally collapse into one line. Now, the angles are increasing in size. Here, each of the angles is 150 degrees. What happens to the positions of the lines as the angles become larger and larger? The angles can get larger and larger. Here they are each 175 degrees. What do you think will happen as the angles get closer and closer to 180 degrees? The angles can get closer and closer to 180 degrees until the three lines finally collapse into one line. In this limiting case, the angles are congruent. The angles have remained congruent as we moved the transversal and the parallel lines. There is another motion to consider. M can move closer to N along T, like this. What happens as M and N get closer and closer? The lines can move together until M coincides with N. In this limiting case, the corresponding angles coincide and become one angle. When line M moves below N, the corresponding angles are still congruent. It seems that no matter how we move the parallel lines or the transversal, the pair of corresponding angles remains congruent.